Let's look at Descartes' rule of sign, what this means. So I'll do this one basically by example, and that's all you really need to do these problems and the concept. So we have f of x. The hypothesis is that f of x is a polynomial. It has to do with polynomials, of course, and with real coefficients. Okay, so we're back to real coefficients. And in our examples, they're going to be integers and stuff, and a non-zero constant term. So, I mean, if it wasn't non-zero, then you just factor this term out, and then you have a different polynomial. So, but you need to be working with a non-zero constant term. Okay, so suppose we have the function, the polynomial, f of x is 8x to the 8th minus 5x to the 7th plus 3x to the 5th minus x squared minus 3x plus 1. Sorry, I had to do something. Okay, so what you do first, and this is kind of the process you go through to do it, is you first count the number of sign changes of each term. So from term to term, what are the sign changes? And generally, you do this in descending order, although it wouldn't really matter. But you put in descending order and all that. So this one's positive. So then if it changes sign, you say you count. So 1, 2, 3, 4. So 4 sign changes. You say 4 sign changes. And then you count down in twos. So you count down in twos from 4. So you say 4 to 0 until you get to 0 or negative. So you count down in twos. Okay, what that means then, this is what we call the positive case. So this means that the number of positive real roots, like on the right side of the y-axis, right? The number of positive real roots is either 4, 2, or none, or 0. Okay, and so that's the concept. Like that's what it will tell you. And then what you do, so that's the positive case. This is the negative case. The negative case, what you do is you evaluate f of negative x equal to 8 times negative x to the 8th. So now you're plugging in negative x everywhere you see x. So basically, if the power is odd, it changes the sign. If it's even, it does not change the sign. Right? That's what it means. So I'm going to go ahead and substitute in, but that's what you're going to get. And then plus 3 negative x to the 5th minus negative x squared. We're going to have to move this over. minus 3 negative x and then plus 1. So you're really just going through and saying that's going to be negative, that's going to be positive, that's going to be negative, that doesn't change, that's going to be positive. That's what that does. So you do evaluate. So you get negative 8 x to the 8th plus 5x to the 7th minus 3x to the 5th minus x squared plus 3x plus 1. Okay, then do the same thing. Count the number of sign changes of the terms. Okay, and I'll just copy that over, but that's what you do. And then you count down in 2's again. Okay, so you get, I'll do it again for you. Okay, so this is negative, so you say 1, 2, 3. Oh wait, I did something wrong. I'm like, that doesn't make sense. This is positive, okay. All right, so this stays positive, right? That's even power, so it's gonna not do anything. Okay, so now let's go back. So you have positive, so 1, 2. That's it, only 2 sign changes. Okay, so 2 sign changes. And so then you count down in 2's just like before. So there's either 2 or 0 negative real roots. Okay, so just like before, this means that the number of negative real roots is either 2 or 0. Let's write that down. So this means that the number of negative real roots is either 2 or 0 or none. So this tells us a lot about what's this polynomial, and tells us how the roots are made up. And so let me just do a couple highlights here. So you have the negative case is 2 or 0. And then you have the positive case is 4, 2, or 0. And so we make this chart. It's one of the easiest ways to do it. So we'll do positive, real. So now you want to structure the number and type of roots. Positive real, negative real, and imaginary. So positive real, negative real, and imaginary. And then the total needs to always add up to what? Think about that. Oops, it keeps doing that. Why is it doing that? Okay. So if there are, so now we do all the possibilities. Let's suppose there are 4 positive real roots and 2 negative real roots. Suppose there are 4 positive, 2 negative. Then how many imaginary roots must there be? There must be 2, because the total must add up to what? Total must always add up to 8. Why? You should know that. Because it must match the number of, or the degree of the polynomial. So there must always be 8 roots. And then you do the next case, and it doesn't matter how you really organize it, but suppose there are 4 positive and no negative real roots, then there must be 4 imaginary, which totals 8. And then suppose there are, now we're going to the next one, right? So we're going to 2. So 2 positive and 2 negative, then there must be 4 imaginary, which adds to 8. And then 2 0, well then there must be 6, adds to 8. What's next? 0. So 0 2, there must be 6 imaginary and adds to 8. And then the last case, no positive, no negative, then there must be 8 imaginary roots. Now in that case, just want to point that out, the last case, then what that's telling you for this graph, we know the basic orientation of the graph. Leading coefficient is positive, even degree, so it must go up on both sides like this. So the last case is basically saying it's always above the x-axis. So it could look something like that and never touches. Otherwise, you can see that it has to either like go down and come back. So it must go down and come back. So you get, and it's telling you basically is it on this side of the y-axis or this side. But it helps you like break down the number of possibilities. Okay, so that's the technique. Go ahead and do the rest of those and practice those. There's other cases to look at, and I might have one in my notes. Okay.